Alright, let us consider the difference between physical change and chemical change. Now, we are given the difference in tabular form. At least we have 6 important differences between physical and chemical change. So the first one here is that physical change is temporary while chemical change is permanent. Of course, physical change is temporary. Let me use sodium chloride in water as an example. So when you pour sodium chloride inside water, we can regain back our salt from the water. So now watch this diagram. This is a process whereby we pour salt inside water. So this is the salt, this is water, then the combination of the two will lead to sodium chloride solution. So, and this solution is known as saline water. So it's an aqueous solution. So, and salt solution is a homogeneous solution whereby the salt will be evenly distributed throughout the solution. We can always regain our salt back because it is not a permanent change. It is rather temporary. And the process in which we can regain our salt back is evaporation to dryness. That is, we are going to sacrifice the solvent, then we will regain our salt back. Now, on the other hand, chemical change is permanent, so we cannot regain our original substance back. So look at a good example of chemical change. This is firewood burns. The firewood will burn down to charcoal and finally to ashes. So the final product cannot reverse back to the original product. That is, we cannot get back our original firewood from the ashes. So that is why we said chemical change is permanent. So now let's go to the second difference between physical and chemical change. Watch, we have no new substance is formed. That's under physical change. Then under chemical change, new substance is formed. So now watch this solution of salt and water. Now, this original salt is still our final salt that we will recover back because this is not permanent change, it's temporary. So after sacrificing the solvent in the process of separation, so through evaporation to dryness, we can still regain our salt back, which will look like our original salt because no new substance will be formed in this process because it's a physical change. But on the other hand, look at the charcoal that is gotten from burnt firewood. The charcoal is an entirely new substance, which is different from the original wood. And then the final ashes is also a complete different product from the original firewood. So it means under chemical change, entirely new substance is formed. So now let's go to the third difference between physical and chemical change. So here we have physical change is easily reversible, but chemical change is not easily reversible. Of course, let us consider our salt and water again. So check it out. After dissolving the salt inside the water to produce the saline water, which is the solution of sodium chloride in water. So salt and water. Now, it is easy for us to regain our salt back through the process called evaporation to dryness. We sacrifice the solvent. And if we want to regain our water back, the solvent back, we use another process. So that means we are not using evaporation to dryness. We can use distillation process. So that means we can get our solvent back. Then we still regain our salt in the process. But on the other hand, chemical change is not reversible. So check this out. If you look at these firewood burns, we cannot get back our original firewood from it again. This is not possible. So that is why chemical change is not reversible. So let us go to the next difference between physical and chemical change. So another difference is under physical change, there is no change in mass. But under chemical change, there is change in mass. Consider the solution of salt and water. You know that mass is the quantity of matter present in the body. Now, the water has its own mass and the salt also has its own mass. Now, if you mix the two together, the total mass will just be the sum of the mass of the salt and the water. Assuming the original mass of the water is 5 kilograms and the salt is 2 kilograms, the combination of the two will give us 7 kilograms. So now, by the time we try to recover our salt back, we observe that after sacrificing the solvent, which is water, our salt that we are going to recover will still be of 2 kilograms mass. And then if we have the opportunity of regaining our water back, then the water will also remain its 5 kilogram water. So that implies that there is actually no change in mass. Although in the actual sense, there will be some loss in mass due to this separation technique, evaporation to dryness. Some quantity of mass will be lost through heat, through the surrounding. But the original salt will remain the same as 2 kilograms salt. And then some of the water will be lost through water vapor, which is steam. So that's why it cannot be 100%. The solvent cannot be 100% complete, but the salt can be complete. Now, on the other hand, check chemical change. Look at the firewood that is burnt. The original firewood that is burnt to charcoal will have more mass than the charcoal because the firewood will be heavier than the charcoal. This implies that from changing from firewood to charcoal, some masses have been lost. And then if we continue burning the charcoal to form ashes, so the mass of the charcoal will also be entirely different from the mass of the ashes, because ashes is a very light substance while charcoal is still heavier. So that means that we have lost some masses in this change process. So let's go to the next change, the next difference between physical and chemical change. Another difference is that under physical change, after everything, mixture is formed, but for chemical change, compound is formed. Let's demonstrate that from the diagram that we have below. Now, in the combination mixture of sodium chloride and water together, when we dissolve sodium chloride inside water, of course, this will produce a solution of salt and water called saline water. And this is a mixture. In fact, it cannot be represented by a chemical formula. This is a mixture. So one of the property of mixture is that they cannot be represented with chemical formula. So this solution of sodium chloride in water is a mixture and not a compound. But on the other hand, when the substance undergo chemical change, the final product will be a compound which can be represented with chemical formula. So now in the burning of wood to charcoal, charcoal is a compound which has a chemical formula. So charcoal is a chemical compound, it's a carbon compound. So it's gotten from carbon. So it is one of the products that we obtain when we burn carbon in air. So charcoal formation can be represented by this chemical formula, carbon plus oxygen to give CO2. So this is a clear evidence that charcoal is a compound and not a mixture. So, and this is one of the key difference between physical change and chemical change. So the end product of physical change is always a mixture, while the end product of chemical change is always a compound which has chemical formula. Now, the last difference that we have here between physical and chemical change is that physical change is not accompanied by heat change, while chemical change is usually accompanied by heat change. So if we consider our picture here for the solution of sodium chloride in water, now we observe that in order to dissolve sodium chloride in water, we don't need heat. It is not until we heat the solution before we can get the solution of sodium chloride, that is saline water. It's not until we add heat to it, or maybe we put it on fire before we can get saline water. So the salt will dissolve readily because it's a physical process. It will quickly dissolve fast inside the water. It's a physical change. So no heat is required. But for the backward process, that is, if we want to regain our salt back, that's where we need heat. So to evaporate it to dryness. So, and this is actually different from chemical change, which always require heat, and it is always accompanied by heat. So more explanation about this is that in this, when we dissolve sodium chloride in water, there is no release of heat to the surrounding. So this is just a physical process where there is no release of anything to the surrounding. It means we are not losing anything to the surrounding. So, and we are not gaining anything from the surrounding. It is neither exothermic nor endothermic. While on the other hand, if we consider chemical change, such as burning of wood, so burning of wood is always accompanied by significant amount of heat. In fact, we need fire, we need heat in order to burn the wood down to charcoal. And this is how it applies to all other chemical process too, all other chemical change, such as neutralization process, everything require, even combustion like this that we have on the board. And then the composition process, most of them require heat change. So, and energy is always lost to the surrounding. So that's one of the key differences between physical change and chemical change. So physical change does not require large amount of heat and it's not accompanied by large amount of heat, while chemical change is always accompanied by significant amount of heat. With all of this, we are able to differentiate between physical change and chemical change. Thank you for viewing this. God bless you.